Testing 1, 2, 3, testing. Okay, circles. Here we have a circle, and we're going to start off with some basic stuff. Okay, circle all the way around, 360 degrees. Okay, if we have a line that goes through the center, there's the center of the circle. What? There's the center of the circle. If a line goes through that, that's called a diameter. Any line that goes from the center to the edge is called a radius. Okay, a radius is therefore half the diameter because it doesn't go all the way across. It goes from the center just to one edge. Okay, so you have a diameter goes all the way across, and as you can see, it's essentially made up of two radii, one going this way and one going this way. So radius is half the diameter. Okay, not too important for what I'm teaching today, but that's some basics. Okay, 360 degrees. So if I put this diameter back on there, and for some reason making little dots in this program is difficult. Um, so just bear with me. That's the center of the circle. This cuts it into two halves. Okay, half of 360 we all know is 180. Okay, so that means this part of the circle is 180, and this part of the circle is also 180 degrees. Okay, that's why when people say you pull a 180 means you turn directly around. And when you do 360, you go all the way around and you're back to where you started from. So 180 degrees, half a circle. Think of a U-turn. That's 180 degrees. Okay? You're coming from, you're going down 301, you missed the gas station, you got to make a U-turn and go back 180 degrees. Okay, some other basic stuff. Let me put some points on here. Okay, let's call this A. We'll call this B. We'll call this C. I'm gonna have to tinker around on how to make this more legible, but you could tell that's an A, that's a B, that's a C. So what we have is we have what are called arcs. Okay, we have what are called arcs. Let's go with need a color, need a color. Okay, from here to here. Okay, see this brownish yellow color that's going from A to C? We would call that arc AC. And you're going to see that notation. Okay, the way you would read that is you would say arc AC. Or you could say arc CA. You could, and you'd be meaning the same arc. Okay? Now, if I go this way around the circle, yes, I am going from A to C again. I am. But to differentiate between the arc I just had up there and this one, I would have to denote this one as arc ABC to denote that it's going through B to differentiate between the one I just had up there, AC. You go a little bit more red here. Okay, so the red is AC, and the brownish color going the other way around the circle. You have to add the B in there, which tells you that it's going through the B, A to B, and stopping at C. So that's arc ABC versus arc AC. Just so we know how to talk about these things. Okay, basics over. let's talk about central angles. Okay, central angles. Let's bring up a clean circle. Okay, central angles come from the center, like that. Their vertex is the center of the circle. Okay, so these work very easily. Okay, so you got this point here where that radius touches the edge of the circle, and this point here where that radius touches the edge of the circle, and you have an arc in between them. So let's say that this angle here at the center, it's more than nine, it's obtuse. Let's say it's 102 degrees. Okay? If that angle is 102 degrees, then this arc is also 102 degrees of the circle. Think of it as a pie or a pizza. Okay? And it's always totals 360. Okay, that portion, maybe that's two, three slices of pizza. Those two or three slices of pizza or pie total 102 degrees of the circle. All right, so if I asked you, let's say this is A and this is B. If I asked you how many degrees, I got to add a third letter. Okay, how many degrees is arc ACB? ACB. Well, knowing that this is 102 over here, you would just simply subtract 360, subtract the 102, that'd be 260 minus two more, so that'd be 258. Okay, so arc BCA, or you could call it ACB, is 258 degrees. All right, and this blue arc here, you would call arc AB or BA, is 102 degrees. Okay, that's a central angle. Whatever this is, shows this out here. Okay, pretty simple. Whatever the interior, the central angle is inside the circle, the arc that the radius touches, that the radii touches, is also 102 degrees. That's a central angle. Okay, central. All right, get a clean circle. Now, inscribed means inside. Okay, so an inscribed angle will look like this. Okay, its vertex is here on the edge of the circle. And it doesn't necessarily go through the center. It can. This one that I drew does not. Okay, so let's say for discussion purposes, this looks a little bit less than 90. Let's say it's 88 degrees. Okay, if that angle is 88 degrees, the arc that it makes is not 88 degrees. The arc that it makes is double that, 88 times 2. Okay, 88 times 2, 176, I think. Let's go with that. Should have a calculator pulled up. Just I don't make stupid math errors in my head. 88 times 2. Yeah, that's right. Okay, so the arc is twice that. Okay, or get rid of all this. What if I said, okay, this arc is 192, 192 degrees from this point around the circle to this point, well, you divide that by 2. Okay, you do 192 and divide by 2, and then you could tell me, oh, this is 96. Okay, so the angle made by an inscribed, where the vertex is not at the center, the vertex is on the edge of the circle, it has a times 2 relationship with the arc across the circle. Okay, and then similarly, if I asked you to tell me how many degrees is this, the other portion of the circle, well, you know that's 192, and you would just simply do 360, and you'd subtract the 192, and then you could tell me how many degrees of the pizza pie the yellow line is. So 168. The yellow line is 168 degrees. Okay, that's inscribed. Okay, see the difference there between central and inscribed. Okay, now the only thing we can do to make it harder is add algebra to it. So what I need you guys to be able to do is I give you, I think red works better. Okay, I give you some sort of angle here, like that, and then maybe another angle here. It goes like that. Okay, and let me put some labeling on here. Let's call this A. Call this B. These letters don't come out very well. D, A, B, C, D, E. And I'll call this center F, just in case I need to refer to it. F as in fail. There we go. Okay. So I could put some algebra on this. All right. I could say that um, whatever this is, if this out here, okay, is x. Let me keep it simple so I don't blow my brain up here. And then the other part around here, let me go like with an orange. Okay, so this would be arc CD. Whoops, we go back to the blue. So arc CD plus the orange part that goes the other way around, which there's several letters there to name it with. We could call that arc CBD or CAD. Okay, to denote that you're going this way around the circle versus this way around the circle. Those two arcs add up to 360. You know that, okay? Because a circle totals 360. So whatever these are, add up to 360. Okay, so if that was X, and let's say that the orange part was, I don't know, I'm making numbers up. It's going to turn out bad. 10x minus 18. Okay, so what do I have to do is I take the 10x minus 18, and I have to add the x, and they would have to equal 360. Okay, and I know this is really messy, and I'm not good at writing on it yet, but I think that's okay. And then I'll show the algebra that 10x and the x get put together to be 11x minus 18 equals 360. Well, give me an equal sign. There we go. And then you're gonna add 18 to both sides. Well, let me go off the, no, it won't. Okay, well, I'm gonna add 18 and add 18. It's gonna be awkward. And then you're gonna get 11x equals 378. And then you divide by 11. So 378 divided by 11 is 34.36. Okay, so I made the numbers up. That's why I got some weird decimal, but 34.36. Okay, but that's how we could add algebra to it. Okay, got to remember that the whole entire circle is 360, and work with that fact. Okay, now let me give you an algebra example with an inscribed. Okay, let's say this goes through the center, so it is a diameter, and then this other chord goes through there. Okay, so we know since that's a diameter, we know that from here to here is 180 because we know a diameter cuts it in half. And we also know from here to here is also 180. So we can use these facts to help us figure stuff out. So if I say, okay, A, B, C, D, if I say that from A to B is 2x, and from A to C is 3x, tell me how many degrees this is. That's supposed to be a question mark. Okay, well, we know that 2x, and 3x total 180. Okay, from B to A to C, that's 180 degrees. So we're going to do, try to space this better. So we're going to do 2x plus 3x equals 180. So that's 5x equals 180. Okay, and you divide by 5. And you think I could do this in my head, but okay, x is 36. And you divide by 5 and divide by 5, x is 36. Okay, well, I'm asking for this, okay? But we know x is 36. So I take that x equals 36 and I plug it in right here. So 2 times 36, I know this is 72 when I do 2 times 36. And since I know that an inscribed angle has a times 2 relationship or divide by 2 relationship, if that's 72, well, this here is half that. Okay, so half that would be 36. So this angle here would be 36 degrees. Okay, so you take the basics of what you know, 360 degrees total, diameters cut it in half, and now you should know everything you need to know about central angles and inscribed angles. And when we give you algebra, we just got to practice on setting it up and solving and answering the question. Cool.